let me first say that the practice final is very much like the final in that there's a lot of word problems. So if you do have trouble with those, you got to practice some stuff tonight, okay, and tomorrow. But let's go over a couple key things. So first things first, and I'll point out some page numbers that you can look up in the book if you do have any questions. Like for instance, on page 724, okay, there's a question. It says the systolic blood pressure. In other words, you go to the EMF and they take your blood pressure, like Paul might do sometime, right? You do blood pressures, right? Yeah, there you go. It's not so hard these days. You push the little button, and but then you have to know how to do it manually too. So, all right. I used to know a doctor who could hold his hand over your arm and then calculate and get your blood pressure. No, I'm kidding. He couldn't do it. That'd be cool, though. I bet somebody figured that out. There was once a guy. Do you guys remember record players, like phonographs? Probably too young to actually have ever had one in your house. Some of you guys. There was a guy back in like the 50s who could look at a record, like just look at the record, and by the grooves figure out what like symphonies was on it. By looking at the grooves. He just knew so much about music, and he had practiced this forever. He went on like the Tonight Show, and then they gave him a record, and he's like, that's Beethoven's Third Symphony or whatever. All right, so kind of cool. All right, anyway. OK, so blood pressure. Normally distributed. Remember, normally distributed means we're talking bell curve sort of thing, OK? Normally distributed with a mean of 121 and a standard deviation of 15. What percentage of the population has a blood pressure above 130? Question 1. What percentage of the population has a blood pressure above 130? What concept are we thinking here? Z-scores, right? So you're going to want to be looking, you're going to want to think, oh, I better be able to calculate my Z-score. OK, above 130. This is a tricky one. Because first you can look at the Z-score. That's the easy part, calculating the Z-score. It's the data item, and this is on your formula sheet, minus the mean divided by the standard deviation. And it writes that all out. But that's all that it is. For this, so this one, it's going to be 130 minus the mean, which it says is 121, divided by the standard deviation of 15, which is, let's see, 0.6. 0.6. That's your z-score. Now, look on your z-score table, and you go to 0.6, and it says that gives you 72.57. Is that the answer to this question?
No.
It is not. Why isn't it? That's the percentage of whatever, in this case, blood pressure, people with blood pressure below 130. It's asking for above 130. So you do 100 minus this, and you get what? 27.43. That's the answer they're looking for. So be very careful on those ones. Okay? You may also see a question where it says below some number. Fair enough. You do the exact same thing, and it's just the z-score value that you look on the chart. Easy enough, right? Okay. It may also say what is the number of people between two numbers. So let's say it was between 130 and below 142. So we'll say 130 is less than or equal to x, which is less than or equal to 142. All right? How do you do this one? You do 100 below 130, which we've already done. Below 130 was 72.57, right? Okay. And then above 142. So you do 142 minus 121 divided by 15 gives you 142 minus 21 is 21. 21 divided by 15, which is what? 0. Sorry. What is it? 1.3? 1.4? 1.4. So you look at 1.4, and you find 1.4 and you say that one is 91.92. That's the percentage below below 142. So if you've got the below 130 and the below 142, what do you do to the two numbers? Just subtract them, actually. Don't divide them. I heard subtract the two numbers, right? And then so that'll be 91.92 minus 27 or minus 72.57. That will give you the in-between amount. Okay? Be sure you know how to do that for the test. Okay. Questions on that one? Uh-oh. You all right? Okay. All right. Let's go on to a slightly different topic. Actually, a very different topic. You will need to know how to do the quadratic formula. You will also need to know how to find the vertex of a parabola, which is a quadratic, just so you know. Okay? The quadratic formula is what? X equals negative b plus or minus square root of b squared, not negative b squared, b squared minus 4ac divided by 2a. Don't forget that one. Okay, big one. The other big one is the vertex, which is what? Xx equals negative b divided by 2a. Okay, see how the negative b divided by 2a is the same as this negative b divided by 2a? You can hopefully remember those together if you want. This is for the actual finding the x coordinates. This is for finding the vertex value. Okay. All right. You may, some people are still right. I'll erase everything but the quadratic stuff. Okay. You may see a question something like the following. Solve. And you have 25x squared. Once you see the x squared, what are you already thinking? Quadratic. Either the quadratic formula or factoring. Good. 25x squared plus 1 equals 20x. And it says solve. And they mean solve for x when they say solve. So how do we do that? Bring the 20x to the other side. So we subtract both sides, 20x from both sides. You end up with 25x squared minus 20x plus 1. And you kind of want it in that form in case you're going to have to do the quadratic formula. And in this case, are we going to have to do the quadratic formula? You can factor that? I can't factor that. Because the only factors of 1 are 1 times 1. And does 1 times 1 added to, or subtracted or whatever give you 20 or negative 20? No, you can't make it happen. So plug into the formula. A, B, C. And by the way, plus 1, negative 20, and 25. And don't forget to do the negatives if they're in there. Okay? And this one would be negative b. So it would be 20 plus or minus the square root of b squared. Negative 20 squared minus 4 times a, which is 25, times c, which is 1. All right, divided by 2 times 25. Okay, you can leave this in once you solve all this, as long as it's if this becomes a radical that you can't do, don't bother plugging it in your calculator. Just leave it in this form if you want. I'm perfectly happy with that. I'll give you full credit for that. But you need to do a little bit more here. 20 plus or minus the square root of, okay, 20 squared is 400. 4 times 25 is 100. So that's going to be the square root of 300 up there. Yep. Square root of 300 divided by 50. Divided by 50. Can you simplify this? Yeah, you can. 300. Remember how we simplify those? You write down 1, 2, 3, 4, 5 all the way up to 10 or whatever, and you start thinking about what the factors go into that. What factors are real easy one into this one? 100, which is, how about 100 times 3? Right? which is 10 squared times 3. So this is going to be 20 plus or minus 10 square root of 3 divided by 50. And then you can actually, I don't think you'll have to do this, but you can actually cancel out the zeros as well. So it's going to be 2 plus or minus square root of 3 divided by 5. That's what that one ends up being. And you can check it if you want. Plug 2 plus square root of 3 divided by 5 into your original question, and that should be the answer, one of the answers. Plug in 2 minus square root of 3 divided by 5 into there, and you should get the same, a correct answer for x. Like this side should equal this side. Okay?
That final answer would be that 2 plus minus?
Yep, this is the final answer. I mean, if you want to do the decimal, you can take the time to do it, but I wouldn't bother. If I were you, I wouldn't even bother doing it. It is a pretty long test. I mean, it's 20 questions, just like the practice one. So it could take a little while. OK, questions on quadratic formula? OK. So the other thing we did with quadratics was figuring out parabolas and graphing them. OK? So let's take an example. Actually, same one. 25x squared minus 20x plus 1. 25x squared minus 20x plus 1. OK? We already have that x equals 2 plus or minus square root of 3 divided by 5. That is when, by the way, this is f of x equals that. When we set this equal to 0, what are we solving for when we get x? Well, no, actually. Believe it or not, we're getting an x. This x value here was when we said 25x squared minus 20x plus 1 equals 0. Right? That means y equals 0, and you're figuring out the x values. On a graph, when y equals 0, is that here or here? It's not this one, because that's like y equals 3, y equals 4, y equals 5. So that's not y equals 0. This is y equals 0, that's y equals 0, that's y equals 0, that's y equals 0, right? OK? No?
Yeah.
On this line, what's the y value of that point? 0, right? Correct? Sorry, Chad. It's tough to see over here. So anyway, so we already figured out the x value, the x-intercepts, if you want. We don't necessarily need to, but we did for this one already. OK? We definitely need to find the vertex on this, though. So this is going to be x equals negative b, which we said was 20, divided by 2a, which is 2 times 25, which is 50. So 20 over 50, which equals 2/5. That's the x value. The y value of that, you're going to plug back into the top up there. You're going to say 25 times 2/5 squared minus 20 times 2/5 plus 1. OK? And that's going to give you the vertex. In fact, in this case, it's going to be negative 11 if you do all this out. OK? Negative 11. So your vertex is going to be 2 points. It's going to be 2/5, comma 11. Sorry, 1 point. 2/5, 11. Thank you, minus 11. OK? And you're going to want to graph that, because they'll probably ask you to graph it. And you'll say, OK, let's see. 1, 2, 3, 4, 5. Negative 1, 2, 3, 4, 5. You should label the graphs, too. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Negative 11. Let's go by 2s. 2, 4, 6, 8, 10. Negative 2, negative 4, negative 6, negative 8, negative 10. 2, 4, 6, 8, 10. 4, 6, 8, 10. OK? So negative 2/5 is what? A little less than a half? So let's say around here somewhere, and negative 11. So down here. About there. OK? When you plugged in this whole thing? OK, let's see. OK, so 25 times 4/25 minus 40 over 5 plus 1. 4 minus 8 plus 1 equals negative 11. No, sorry, you're right. 4. Is that, let's see. It wasn't negative 25, was it?
No.
No, you're right. So it's not negative 11, is it? It's 3. Thank you. Thanks for checking me on that. Negative 3? Negative 4 minus 8, negative 4 plus 1, negative 3. Thanks for checking me on that. Good call. OK, so it's actually 2 hat negative 3. OK, 2/5 negative 3 is right about there. I guess we could have done this one in ones, but that's that. OK, now let's find the y-intercept. The y-intercept's an easy one to figure out because x is a 0. So for this thing, we do 25x squared minus 20x plus 1, well, equals y equals this. So in this case, it's going to be 0 minus 0 plus 1. So that means y equals 1 when x equals 0. That's easy. That's nice. Y equals 1 when x equals 0. OK, right there. And then we would probably want to put in our intercepts as well. So our intercept's 2 plus square root of 3. Square root of 3 is what? 1 point, what is it? 1.6 or 1.5? Let's see, 1.5 is 1.5. 1.7 maybe? 1.73. OK. So 1.7 divided by 5. 0.346. So the x-intercept is 0.3 and 0. And then what's the? Yeah, 2 minus that divided by, it's going to be, let's see, it's going to be even less, isn't it? 2 minus 1.7, 0.3 divided by 5? 0.06. 0.006. What was the other value? Oh, 1.7.
No, you said 1.7 divided by 5, right?
Yeah, yeah. What's 0.06 divided by 5? OK, well, should be about there. OK? It's kind of a little too small on my chart here. But anyway, now that you've got all those points, you can actually draw it. So it's going to be like, even though I didn't quite get it right, but it's going to be, you're going to draw it on there like that. So practice a couple of those. There's one that's a good one on your practice exam. OK? All right. Another one that you might see. OK? Are people still writing this one down? No? OK. Another one that you might see are these probability questions with a chart of all the different probabilities. OK? So let me write some of these down. Car accidents in Florida. We've got a number of Florida examples. Car accidents in Florida. OK? So you can have when the driver, this is kind of morose, when the drivers lived, when the drivers died, and then the total. OK? And then when you wore your seatbelt, OK, when you didn't wear your belt, and then your total. OK? All right. And your total. OK, so we have 4, 1, 2, 3, 6, 8. 1, 6, 2, 5, 2, 7, 5, 6, 4, 8, 9, 5. 5, 1, 0, 1, 6. When I was a kid, I always hoped I could stand up in front of a crowd of people, read off a bunch of numbers, and have everybody pay attention. All right, just kidding. 2, 1, 1, 1, 4, 1, 2, 8, 7, 8, 1, 6, 4, 1, 2, 8, and 5, 7, 7, 0, 0, 6. OK, so what we want is probabilities here. What's the probability of survival, drivers lived, given that you wore your seatbelt? So how are we going to do that? we're going to say, look, here's where we wear our seatbelt and where we lived. Given that we lived, right? Or no, given that we were wearing our seatbelt. So it's going to be 412,368 divided by what? The total. 412,878. In this case, 0.9988, which is 99.88%. Sorry, the total? Yeah, this is the total in here. Sometimes you'll have more rows here, and they won't give you a total. You have to do the total. In fact, that's probably the first thing you should do, is total up all the bottom and total up all on the side, because you're going to use most of those values at some point. OK? All right, given that you wore the seatbelt. So forget about the other ones, and just look at the column that you're worried about, or the row that you're worried about. OK? We could have also said a kind of a slightly different one would have been, find the probability that if you weren't wearing your belt, you died. Right? Here, divided by the total there, right? Yeah, 1601 divided by 164,128. Don't do that. It looks much. The probability of not surviving. It's actually 1%. So don't pay any attention to that. Most of the reason this is true, I think this is like all car accidents, like granny going across the street and like accidentally going on the curb, you know, or whatever, right? Bumper, fender benders or whatever. What's that? Yeah, exactly. I know. Chris said, don't wear your seatbelt. Oh, great. I'm in trouble. I'm in trouble. OK, but those are the given ones. Now, how about this? Find the probability that no belt was worn, given that the driver died. OK? Probability that no belt was worn, given that the driver died. So what you do is you say, given that the driver died, that's this way. All right? Given that the driver died, no belt was worn. 1601 divided by 2111. Right? Because now it's just this way. Given that you're on the died column, how many didn't wear their belt? Well, this is actually 75.8%. 0.7584. 75.84%. So to comment on Zach's question, or point that I said don't wear your seatbelt, if you're in an accident where you're going fast enough that you will likely die, like a bad accident, not wearing your seatbelt's really bad. 3/4 of the time, you're done. Okay? And this may or may not include people with airbags and all that too, which are another safety feature. Right? Okay? All right. Let's see. Let's do this. Let's do this. Let's look at a couple other. This one's, but that's about all we can do for that one. I got one for you. What? OK. We only went over this like once or twice, but you're going to have to do this. All right. Let's say we've got some values. 20, 62, 18, 48, 49, 50, and 20. OK? How are we going to find, first of all, let's find the mean. That's an easy one, right? 20, well, let's just do it. 20 plus 62 plus 18, whatever. So right now, 20 plus 62 plus 18 plus 48 plus 49, 50, 20. Divided by what? 1, 2, 3, 4, 5, 6, 7. Divided by 7 gives me 38.14. So 38.14. OK? That's the mean. What's the median? Well, what do you have to do if you want to find the median? Put it in order. 20, 20. Oh, there's an 18 in there. 20, 20, 48, 49, 50, 62. And then you look at the one that's in the middle. So I normally just go like cross one off, cross one from the other side, cross one off, cross from the other side, cross one off, cross from the other side. This one happens to be. So 48's the median. If there's 2 in the middle, average them. Okay, that's easy. The mode in this case? 20, which is a weird, doesn't really tell you that much about this data set because it's kind of a weird one that both happen to be 20. Now, you will have to figure out the standard deviation. I know. It's on your sheet. You just got to remember how to read it. Okay? So here's what it says. It says standard deviation equals the square root of the sum of the data item minus the mean squared divided by n minus 1. And n is the number of items. So what you're going to need to do in this is you're going to need to take each of these values, subtract the mean, and then square that and add up all those squares. OK? Sorry? No, it's going to be 18 minus 38.14. So it's going to be 18 minus 38.14, right? Plus, actually, squared, plus 20 minus 38.14 squared, plus 20 minus 38.14 squared, etc. So you do all that, you add them all up, you square them, you get all the different values, okay? And then you do the, I mean, I might do this. I would probably do this. I would probably have a column now, right? And I would say 18, 20, 20, 48, 49, 50, 62. In the interest of time, let's just pretend the mean was 38. It'll be pretty close anyway. So, and then you're going to have item minus, data item minus the mean. And then you're going to have data item minus the mean squared. And then you're going to add them all up at the bottom and get that number right there. OK? So let me just do this real quick. 18 minus 38 equals negative 20. And 20 minus 38 is negative 18 and negative 18. And 48 minus 38 is 10. And 49 is 11 and 12. And 62 minus 38 is, that's not right. 62 minus 38 is 24. Well, that didn't make sense. What did I do wrong? Oh, yeah, you're right. So 12. OK. 1, 2, 3, 4, 5, 6, 7. OK. And then I square all these. So I get 400, and I get 18 squared is 324, 324, 100, 121, 144, and 24, 576. 576. And I add those together. 576 plus 144 plus 121 plus 100, oops, plus 100 plus 324 plus 324 plus 400, and I got 1,989. Okay? And then I do 1,989, so it's going to be the square root of 1,989 divided by n minus 1. 1, 2, 3, 4, 5, 6, 7. 7 minus 1 is 6. Divide that by 6, and then take the square root. That happens to be the square root of 331.5. And then I take the square root, which is here, and I get 18.2. 18.2 is my standard deviation. And if you look at the numbers, well, there's a pretty big range here. So 18.2 from these numbers for a standard deviation is pretty good. Like that sounds about right. Okay? All right. OK, so we did some probability charts. We'll do some more of those when we get to the thing. Quadratic formula, did the parameters. Sometimes it'll say something like, here's a model, and then here's a graph for the real data, and the model is for the real data. How good is the model for a certain value? So let me show you an example. People still writing these down? OK. let's say, I probably shouldn't make this up out of my head, but let's say there was a chart here, and it had a bunch of values on it. I don't know, like this, like that, right? And this was like 62, and this was 51, and this was 48, and this was 47, or something like that. And it went down like that, and it told you the values on there. And it said, there's an equation here that's x squared plus 2x minus 3 that models this, right? How close is the model for this point, right? Well, what you do is you plug in the value at this point here, whatever this says this is, like, I don't know, 16, and you plug that in, and then you find out how close it is to 48, and if it's above it or below it. The model should be pretty close. If they give it to you, it should come out pretty close for the values here. They might also say this is for when x is above a certain age. So let's say for this is the number of, let's see, this is the, I don't know, the number of hours of sleep. Well, it won't be 62 per week. I don't know. Number of hours of sleep per week for people after age 50, right? So after age 50. So if it says, look at value, this is for value 1, 2, 3, 4. If this was after age 50, which one would this be? If this is x, it's going to be after age 50, so it's going to be how old? If it's 3, x equals 3 from 50. I'll give you a hint. This is 50. So what's this one? Yeah, this is 50. Yeah, I guess if it's after 50, it'd be 50, and this would be 51, 52, 53. But you plug in the x value, like 3. In this case, it would be 3 squared plus 2 times 3 minus 3, right? 9 minus 6 minus 3, 3. Well, it's a terrible model, right? If it was supposed to be 48, right? That would be a terrible model. It would be way underestimating it. But whatever, the model, this would maybe be, instead of x squared, it'd be like 20x squared or something like that. So anyway, you have to check the model against the answer in the graph. Okay? These aren't really that hard. You got to think about them, though, sometimes. They're like multiple kind of step sort of things. OK. Sometimes you've got your formula on here, and it may ask for something other than the easy answer, like the answer that's in the formula. You got to know how to do some algebra with only the easy ones of these. So for instance, if you were looking at future value for simple interest, what's that? How what?
What I need to look for to study, to go over?
This is models. So I don't know what chapter this one is. This is, I don't know where. Let me see if I can figure out where it is. No, I don't know off the top of my head where it is. We'll look it up in the book. I forget where in the book it is. You got to look up models for that, though, like modeling data. OK? All right. Let's say that I gave you a future value for simple interest problem, right? And you're going to have this formula, A equals P times 1 plus RT. And that gives you the future value for the simple interest, all right, with some principal. Now we know how to do that. If I said, what's the future value of $5,000 at a rate of 5% for 2 years, right? You could plug that in. But what if I said, you've got a future value of 8,000, your principal was 2,000, and your rate is, I don't know, 6%. How many years is it going to take to get from your principal to your value? Yeah, plug it in and solve for t. That's what you need to do. Okay, so you might need to do something like that. Where in this case you'd go, let's see, you'd go 2,000 times 1 plus 0.06 times t equals 8,000. Right? And then you start solving for it. 4, because you divide both sides by 2,000, equals 1 plus 0.06t. That's going to be 3 equals 0.06t. 3 divided by 0.06 equals t. So how many years that is? 3 divided by 0.06. What'd you get on that one? 50 years? That'd be bad. 50 years. Right? Yeah, because you're actually doubling it twice, so it would take a while. Even though it's 6% interest, that would take a while. Yeah. Simple interest isn't that great because there's no compounding of your interest. What that's saying is basically after a year, you get your interest back, and then you start back over with 2000, and the next year you get your interest back, and you start back over. So it's not, you don't get that compounding effect. That's why it would take 50 years to do that. Don't use simple interest. Don't try to go into a simple interest loan unless you're the one paying it.
Yeah, if you put the 2,000 times 1 plus.
Yeah, you could do it that way.
Okay. All right.
Yeah, and then you just, yeah, I like to divide it out first because it's easier, but
Okay.
you can certainly do it the other way. Okay? All right. Okay. You may see a question like this. We had one of these on the last quiz, and a bunch of you guys were like flummoxed by it, right? 6x plus 2y equals 7. 5x minus 3y equals 12. Solve for that. Solve for x and y. Okay? Remember, there's two ways to do this. There's either addition or substitution. This one's probably a toss-up about which one is easier, addition or substitution. But you can't really, it's a little tricky to do this one with addition, but you can. Okay? So let's say that we wanted to get rid of the y. Well, what are we going to have to multiply these? We have to multiply both of these equations in this case. Right? We have to multiply the top one by 3 and the bottom one by,
-3.
No.
what's that?
-3 and
No, actually. You could do, yeah, it's going to be 3 of if we wanted to get rid of the x's, we could multiply the top by 5, but the bottom would have to be -6, because you want those two to be 0 when you add them together. So you need one to be negative the value, the other one to be positive the value. Okay, so in this case it's 3 and 2, which would give us, let's see, 18x plus 6y equals 21, and it would give us 10x minus 6y equals 24. And then we could add them together, and we would get 28x equals, let's see, 45. X equals 45 divided by 28. And there's your answer. That hopefully will come out a little nicer. But there's your answer for that one. And then to get the y, you just take that and plug it into either this one or this one, and you're good to go. And then check it. Always check these, because you can. It's so easy to check these. It's just ridiculous if you don't check it. Because if you get it wrong, then you check and it's wrong, you just redo it until you get it right. Christine.
And you can plug in that x in any of those equations.
You can plug it into any one of those, and it should be right. It should work fine. Yep. Yep. Okay. Question on that one? Got to practice this a couple times. Okay. All right. Let's see. If you're going to do a scatter plot, okay, if you're going to do a scatter plot, and that gives you a bunch of values in a chart, well, wouldn't be two, be one like values, like 6 and 2 and 8 and 3 and 5 and 1 and 10 and 4. If it tells you which variable to use for x, make that one x. So if this was like, I don't know, days of sun, and this one was, I don't know, the number of carrots you get when you grow your garden, right? More sun, more carrots, maybe. I don't know, right? So if it says use the days of sun as the independent x variable. Don't worry about the independent means. Just look at where it says x, right? Then you're going to have you're going to do your plot, and it's going to be 6 and 2. If it says use this one for x, write it down, right? That's x, and this is y. And you're going to go 6, 1, 2, 3, 4, 5, 6, 2, 1, 2. And then you're going to go 8, 3, 3, 5, 1, 1, 2, 3, 4, 5, 1. And then 10, 4, 1, 2, 10, 4, get it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 3, 4, right? And then you're going to say, is that a positive correlation, negative correlation, whatever? Right? Well, this one happens to be positive. Okay? Good. All right. Those are the big things from the test. I tell you what, let's take another 5 minutes. Let's come back at 20 after, and then we'll go over whatever problems you want on the practice final. Okay? And if you guys came on Wednesday or Thursday and don't want to stick around, cool. Sorry, it looks a little funny up here. Number 18 on the test, the practice test. 22 cars in the parking lot. Robert wants to find some statistical data concerning these cars and finds out how old the cars are. The results can be read from the following frequency polygon. So what this is a frequency chart that tells you how old the car is and how many cars there are that fit that age. Okay? So this is why it might have been a little tricky. Okay. So what are the questions here? Questions are, find the modal car age. The mode is the one with the most. Well, that's easy. Because there's 4 cars that are 1, 6 cars that are 2, 7 that are 3, 3 that are 4, and 2 that are 5. So what's the one that's the modal age? It's got to be 3, because there's the most cars are 3 years old. There's 7 cars that are 3 years old. This has got to be 3. Okay? The median car age. This one's a little trickier. This one you probably have to write it all out.
Yeah, that's what I did.
All right, so I would do it this way. I would say, look, there's 4 cars that are 1. So you have 1, 1, 1, 1. And there are 6 cars that are 2. 1, 2, 3, 4, 5, 6. And there are 7 cars that are 3. 1, 2, 3, 4, 5, 6, 7. And there are 3 cars that are 4. 4, 4, 4. And there are 2 cars that are 5. Now you start slashing them off. So let's go 5 this way. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10. 8, 9, 10. Oh, there's 2 3s right in the middle. So what's the median? 3. Because your average 3 plus 3 divided by 2 is 3. So the median is 3.
You know, if you add 1 plus 2 plus 3 plus 4 plus 5, divide by 5, it's 3 also.
Oh, lucky you, I guess. But that's
That's
yeah.
I was just like, that's not how you do it.
Yeah. The mean age of the cars. Okay, so you're going to have 1 times 4 is 4. 2 times 6 is 12. 3 times 7 is 21. 4 times 3 is 12. And 5 times 2 is 10. Add all those up. You get 6, 7, 8, 9. 1, 2, 4, 5. 59. You add all those up and you divide by the total number of cars. 4 plus 6 is 10, plus 7 is 17, plus 3 is 22. 22. So 59 divided by 22 is the mean. See, does that make sense? 2.68. 59 divided by 22, 2.68 is your mean. And then it says find the standard deviation. Well, this is what we did 10 minutes ago, right? And it's going to be annoying because there's so many data values, although you really don't have to do them all, right? You would do 1 minus 2.68. And then you're going to take the square of that value. But then you're going to multiply it by how many you have? 4. because you're going to add them 4 times, because you're going to do it 4 times. Then you're going to do 2 minus 2.68 squared, but now there's 6 of those. And then you're going to do 3 minus 2.68 squared, and then there's going to be 7 of those. And you keep doing this for 4 and 5 as well. And then you add those numbers up, divide by n minus 1. What's n in this case? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I guess we already figured that out, 22. So you're going to divide by 21 and take the square root. Practice that. I'll give you a sec on this one.
So
That was the
when he's saying
Here, we'll do it. We'll make sure we got the right answer here. 3 minus 2.68, and then you're going to do 4 minus 2.68 squared times 3. And then you're going to do 5 minus 2.68 squared times 2. I'll do this on my calculator. What's that?
D.
D? That's what we're doing right now.
Why is 3 in first?
What?
It's 4 numbers, no?
You just don't get what's going on here with this data.
That 3.
There's 1, 2, 3, 4, 5, 6, 7 not threes.
Go back all the way to
4 minus 2.6.
4 minus 2.8 squared times 1, 2, 3. There's 3 4s. Yeah, this is why this is a little more involved than you'll probably be asked to do tomorrow, just so you know. But you will have to calculate standard deviation. So the first one is going to be 2.8224 times 4. 11.29. And this one's going to be 2 minus 2.68 squared times 6 is going to be 2.77. And this is going to be 3 minus 2.68 squared times 7. 0.7168. And then it's going to be 4 minus 2.68 squared times 3 is going to be 5. I know you can't see this on here. 7.2. And then 5 minus 2.68 equals that. Squared times 2 is going to be 10.77. So I'm going to add all these up. 10.77 plus 5.2272 plus 0.7168 plus 2.77 plus 11.29, and I get 30.7688. I have to divide that by 21 because it's n minus 1. And that gives me 1.465. I take the square root of that. And I get 1.21 is the standard deviation. Hopefully that's close to what the answer is. Standard deviation 1.2. Okay.
My question on usually is whenever I would problem, if you give out like the thousands or the hundreds decimal place.
Yep.
Some of these like the answer when that's like 10 of the hundred
Mhm.
thousands or thousands, like am I gonna get negative credit for
No.
going too far?
No. I'm not gonna worry about if you don't round to. I don't think any of the questions tell you where to round to. So, just generally either dollars or cents.
Yeah, you don't wanna-
You want to round to one of those, but otherwise, yeah, either straight up dollars or to the hundredth. I wouldn't take points off if you did either. And then these ones, yeah. I mean, if you gave me 1.2164333, I mean, whatever. I'd be, I'd look at it and see 1.21 in me, or 1.2 and be good. Okay? What happened, Mark? Oh. There are actually a couple calculators left. Wait a minute, there was one more. Okay. All right. I don't want you to stress about this exact problem, but I definitely want you to know how to calculate standard deviation, this formula that we had here. Okay? And it's on your formula sheet, so as long as you understand it, you should be able to do it. Okay? All right. What other questions do you want to do from the final exam, or the practice exam?
The equation for recipes is
Ah, good question. OK, so we went over this the other day. Let's look at what the question was here. The recipe one, right at the beginning, right? Muffin recipe. Here we go. A muffin recipe calls for. OK. Let's just try to walk through how you might think this if you didn't remember the formula, because that's kind of more important. OK, let's say you wanted to make 2 dozen. The recipe says to make 2 dozen cookies, and it says you have to do 1/4 cup of brown sugar. OK, if you wanted to make 4 dozen cookies, what would you do to this recipe? OK, you double it, right? So you would be going from 2 to 4, right? Which is saying 4 divided by 2 times 1/4. Right? It's going to be doubling it. You're saying the number that you want divided by the number you have times the amount. So let's use that to figure it out. So a different way. Let's say you wanted to go to 8 dozen. Wouldn't it be the same calculation? Right? 8 divided by 2 times 1/4. Right? Isn't that the same idea? Okay, because you're thinking, I always just work, if you can't remember it, work it out. Just work out an easy one that you know. It's going to be 4 times as much, because 2 times 8 is 4 times as much. So let's say you wanted to go from 2 dozen to, I don't know, 1.2 dozen for some reason. Right? You wanted fewer cookies, and somehow you came up with 1.2 dozen made sense. Right? It wouldn't really normally, but you'd go, all right, well, that's actually less than half. It's going to be a number smaller than 1. 1.2 divided by 2 times 1/4 gives you the amount. All right? So let's see if we can do that for this problem. A muffin recipe calls for 3/4 cup of sugar for 3 dozen muffins. 3 dozen. If you want to make 8 dozen, well, how are we going to do it? We're going to go 3 to 8, which is 8/3 times 3/4. Cancel, cancel, 2. Is the answer 2 cups? Yes, it is. Okay. Now that we kind of walked through how to do it, you should be able to do it for the rest of your life, right? So when you guys have 16 children and you want to look at a recipe that says, makes 48 pancakes, and you want to go, well, I got to make 320 pancakes. You do it. Okay? All right. OK, what's another one you want to do? 14. OK, 14 says the population P of bass in a lake is predicted by the function P equals 3,600 divided by the quantity 1 plus 7e raised to the negative 0.05t.
How do you do that in the calculator?
Ah, good question. How do you do it in the calculator? Well, first of all, where t is the time in months since the lake was stocked. In other words, they put a bunch of fish in the lake, and the fish increased using this formula. And it says evaluate P of 12. P of 12. T is the time in months since stock. Stocked? Since it was stocked. P of 12. OK, here's what you're going to do. First, you're going to plug into the formula. Right? Equals 3,600 divided by 1 plus 7e raised to the negative 0.05 times 12. Okay? Now, this whole thing is e raised to the whole thing. So this part has to be in extra parentheses, by the way. You just got to make sure there's parentheses around these two numbers. So let's try typing this into the calculator. You can do it all at once if you want to. 3,600 divided by parentheses, because the bottom is going to be an addition, so you're going to need parentheses for the bottom. 1 plus 7. Some calculators make you do this. Doesn't matter if you do or not. Times whatever the E button is. It might be second E, or it might just be an E button, or it might be Shift E, or something like that. This means, when you type that, it means E raised to the power. That's what it does already. I've never seen a calculator where it didn't do that. If yours doesn't, maybe it's special. But just type E. Yep.
Is it a capital E okay?
That's not the right E. It's got to be a lowercase e. The capital E means like a scientific notation. So there's got to be one on here. Let's look for, is there an ln? It's going to be near ln because they're opposites. There you go, e to the x. So it's going to be shift e ln. So hit shift ln. Wait, did you already get rid of the e?
Yeah.
OK, there you go. And that means e raised to the whatever power. I think it means e raised to whatever power it is. OK. I saw a W up here, I would plug this in. So 2Q plus 3 times 353 minus 3Q equals 520. Then I would solve 2Q plus 3 times 353, and you have to distribute through this. 3 times 353, 1,059 minus 9Q equals 520.
And how you call that?
Distribute?
Oh, distribute.
Yeah, distribute the 3 through both of these. Yep. And then this would be negative 7Q equals 520 minus 1,059, negative 539. Divide both by negative 7. And you get 77. Q equals 77. So a quarter pounder has 77, what is this, milligrams of cholesterol. Don't eat too many of them if you can help it. And then to figure out W, just plug it right back in here, the Q right back in here. W equals 353 minus 3 times 77. 353 minus 3 times 77 equals 122. 122 for a Whopper, 77 for a quarter pounder. I think one time I had like a double Whopper with cheese, and I felt like I was going to die afterwards. It was so yummy. It really was delicious. Now I kind of want one, but once a year maybe. I used to order them with cheese all the time, but I don't anymore. And I always order my Whoppers without tomato. Like the one thing that's actually probably good for me on the whole thing, I always get rid of. Oh well. I do keep the onion on there. That's good, yeah. All right. Any? You know how KBR has now started putting on the food description, it puts you should eat this often or not. I don't know if you noticed that. It's green for eat often, yellow, eat occasionally, and red, don't eat often. Well, first of all, like 80% of the foods are don't eat often. Like it's like fried, right? And then at the end, I look at my plate, I'm like, all red. I need to work out more and I need to eat better. All right, any others?
Real quick on that standard deviation.
Standard deviation.
Yeah, the 2.68.
Was it 2.68?
Yeah, that
Yeah,
was
yeah.
D, though.
Oh, standard deviation?
Yeah, the D. So 4 minus 2.68, and then the square.
Well, almost, yeah. For that one you do. Yep. 4 minus 2.68 squared.
Right.
And then you have to multiply by the number of 4s, which in this case was 3 4s, I think. Yeah, 3 4s.
Yeah.
Because remember, if you're doing standard deviation, you have all the different numbers. So you have 2 and 6 and 4 and 9 and 21, right? And you get the average, the mean, right? 8, 12, 21,
No, this is
42.
for 18, yeah.
I know. I'm telling. But for 18, it was different because it was like, well, it was like 2, but there were the age of the car. The ages were 1, and there were how many of those? 4, and the 2, and there were 6, and 3, and 7, and 4, and 3, and 5, and 2. You have to keep that part in mind when you're doing this.
Right.
So for the first one, it's going to be 1 minus the standard or the average 2.68 squared for each one of those 4s. So you could do same thing plus another one, same thing plus 4 times. But when you add something together 4 times, you're just multiplying it by 4.
So the data item is 1 minus like
The data item is the 1. Yeah, but there's 4 of those.
I thought it was the frequency. So I did
No, it's the data item is the age. Because that's really what you're trying to find the spread of, the age, not the number of cars. Right? Okay. All right. What else? How about this one? Anybody like to get this one? formula n equals t squared minus t divided by 2.
Which one's that one?
Number 10 describes the number of football games. So n is the number of games played in a league with t teams. That's the teams. It's the number of teams. Okay? And it says use the information to find the number of teams that belong to a league which has 36 games. 36 games. So the 36 games goes with what? The n or the t?
That goes with the n.
It goes with the n.
Yeah, 4.
Good. So it goes with the n. So let's plug that in here. What do you get? You get 36 equals t squared minus t divided by 2. And it says find the number of teams. So can I solve for t in this case? You can actually. You can't do it easily. I mean, you can't do it simply. But first things first. How do you get rid of that 2? It's being divided, so you got to do what to it? Multiply it by 2. So multiply both sides by 2. You get 72 equals t squared minus t. Does this start to look familiar? You're going to want to factor it eventually. Yeah. So let's get this in a form where we can factor it. We can't factor it yet, can we? No. Move the 72 to the other side. Subtract 72 from both sides. You get 0 equals t squared minus t minus 72. Now Adam's absolutely correct. You can factor it. And hopefully you can, or you do the quadratic equation. But this one, believe it or not, is factorable pretty easily, actually.
But this one we have to factor?
You don't have to. You can do the quadratic equation, but you're going to have to do it to figure out the answers. So what are the terms? What are the
FOIL?
yeah, well, you're going to have to do FOIL, but you're going to be doing kind of reverse FOIL to factor, remember? You try to figure it out when you're factoring. What's the first thing we do when we factor this?
Negative 72.
Negative 72. What goes into 72?
1 and 72.
1 and 72. But you're never going to get 1 out of a 1 and 72 when you add them.
2 and 36.
2 and 36, same thing.
Or 72 divided by 3.
Think your times tables. There's a big one in there. What times what equals 72? Times tables. 8 times 9. 8 and 9. Right? And if we need a negative 1, because that's what this one is, when you add 8 and 9, what's going to be what? You want a negative 1 when you do 8 and 9. So you're going to have what? Positive 8 and negative 9. That'll do it. Okay? So now there's one other step to this. You're not quite done yet. Now you need to say, OK, look, if it equals 0 on one side, we can say t plus 8 equals 0 or t minus 9 equals 0. When you do t plus 8 equals 0, you get t equals negative 8. When you do t minus 9 equals 0, you get t equals 9. OK, so you have two answers here. Well, which one's right? The number of teams. Which one of these has to be the right answer? 9. You can't have negative 8 teams in some other universe. What's that?
You can plug it back into the equation and check.
Both of them will work.
Both of them work, you get 36?
Yep. Try it. 8, negative 8. Negative 8 squared is 64 minus 8. 64 minus 8 is 72. 64 minus 8 is 76. 76 divided by 2 is, nope, I didn't do it right. 64 minus 8, is that, oh, 64 minus negative 8. 64 minus negative 8 is 72. 72 divided by 2 is 36. Check. So negative 8 would work. Both answers work. You proved it. You solved the quadratic formula and you proved it both work. The other one, 9, works too. 81 minus 9 is also 72. 72 divided by 2 is 36. Yeah. Yeah. It just doesn't make sense. It just doesn't make sense physically. Yeah. Like you can't have negative 8 teams. All right, so you don't have negative 8 teams. You have 9. Okay. If in some weird universe with My Little Ponies and stuff, you have negative 8 teams, they could also have 36 games. Okay.
In Djibouti.
In Djibouti. It's a magical world called Djibouti. I wish this was magical. You could wake up.
Couldn't I plug 9 squared minus negative 8?
No. You're just doing either 9 or negative 8. So you got to plug the same t in both places. Oops. This is going to be, if you use 9, it's going to be 9 squared minus 9 divided by 2. Or it's going to be negative 8 squared minus negative 8 divided by 2. You can't mix and match there. No. Okay. All right. Any other ones you want to do? We did a vertex one. We did one like this, probability ones. This one's a little more difficult because it involves 3 different sets, right? Brown, blue, green. So you got to add. This is the one where you're going to want to add to start off with. 22 plus 18 is 40, 50. 18 plus 12 is 30 plus 50 as well. Did I get that right? Doesn't that look right? Yeah, you get it.
You got 20.
This is 60, isn't it? What's that? No. 22, 32, 40, 50.
Yeah.
20, 40, 50. Yeah, 50 and 50. Okay. And then you do this way too. 22 and 38 and 40. Okay. And I forget what the questions are on this one. Questions are probability that a student does not have brown eyes. Okay, what's the probability that the student has brown eyes? Or doesn't have brown eyes is fine. 38 plus 22. 38 plus 22 equals 60. 60 out of the total. Well, the total is, let's see, 100. A student does not have brown eyes, right?
It's 100.
So is it 100? 40 plus 38 is 78, 80, 90, yeah, 100. Divided by 100. That is 100.
How'd you get 100?
Because it's 50 males, 50 females.
If you add all these up, you'll get 100. The males, if you add all those numbers up, you'll get 100.
But you have to exclude.
For this one, well, what we did here is we said, look, does not have brown eyes.
Yeah.
Do the brown people have brown-eyed people have brown-eyed? Yes. So it's just this column plus this column, 60 divided by 100, 0.6. Has brown eyes or blue eyes. The or is is where you add things. So who has brown eyes? Or you could do this. You could say, look, brown eyes or blue eyes. So add those together. 78 divided by 100. Okay. Now, the next one's the tricky one. Is female or has green eyes. Okay. So watch how we do this one. Is female. How many females do we have? 50. So you can do 50 out of 100. Or has green eyes. How many green-eyed people do we have? 22 out of 100. But you double counted. You double counted females who also have green eyes. You double counted that. So you have to subtract 12 out of 100.
So we can just exclude female period and just look at them.
You can't because you need probability that they're female or green eyes. Right? So you have to count a female brown eyes, does she count? Is she female or blue eyes? Yeah, she is female. Right? The only people that don't count are these guys, and that's it. Everybody else counts. Okay? think, here we go. And then finally, is male given the student has blue eyes? So we don't care about these ones or these ones. We only care about these ones, and we only care about whether they're male. Because we know they have blue eyes, what's the probability they're male? Well, now it's just going to be 18 out of 38. Good? Same. Yep. Okay. All right. Listen, I will be around. If you guys want to email me tomorrow morning with more questions, I'll be around tomorrow morning. I have meetings. Believe it or not, I have meetings at 1500. So 15 to about 16:30 or so, I'll be in meetings, and then I'll come straight here. So you won't catch me then, but you can catch me before that if you want to email me. I'll check my email during the morning.
What time would be a good last email?
Say 1400 or so. Kind of after that, I'm already headed this way. Yeah.